We are live. Assalamu alaikum, everyone. Welcome to today's exciting session titled Navigating the Era of Experience with LLM-Driven Reasoning. We are especially honored to welcome our dear guest, Azzeddine Chenine. He's a senior research engineer at Instadeep and Google developer expert in machine learning. Azzeddine, we are honored to have you with us today, and this stage is yours.
Thank you. Okay, I think we can start. So hello everyone. I hope everyone is having a great start of the week so far. It's a pleasure to be here, my second time at the AI Summit. Thanks for the team for organizing this event and also the invite. I'm Azzeddine. I'm a research engineer at InstaDeep. I'm also like a Google developer expert in machine learning. And recently like a mentor for Google for startups in the Middle East and also North Africa and also Turkey. Actually, what we do is that we do help startup land their seed round funding by shaping their product and also crafting a way where they can use AI to help their product shine even more. We're gonna start this presentation with this slide. As you can see here, I'm trying to showcase like three things that are labeled as complex tasks for humans, either end-to-end lab experimentation, chip design, or even like deep mathematics and physics. Although like the LLMs had like a great race so far, they still fall short when it comes to solving these kind of tasks. Maybe because they haven't been trained to solve such tasks. And maybe because we don't understand the utility of these LLMs when it comes to solving these tasks. So as you may have seen, the pursuit of steering LLMs towards solving deep, complex tasks have been I would say, the state of the art lately by OpenAI or DeepMind by having their deep research product. And also like NVIDIA released CRUD, which is like foundation model for physical AI that require like deep reasoning in order to solve such tasks that are mostly robotics tasks. And in this presentation, we're gonna like have sort of I would say sort of like also like a reflection on this poem that says like we shall not cease from exploration, and the end of all our exploring will be to arrive where we started and know the place for the first time. The phrase "know the place for the first time" suggests that by returning to the starting point after a journey of exploration, we can see the place clearer with deeper insights. And if we go back a decade ago, we're gonna find that in 2017, I think, or in 2016, Google DeepMind AlphaGo agent played against who's regarded like the best Go player in the world. And Go is like a board game similar to chess, but it's way harder than chess. It's actually like if you take the list of board configurations you can design with Go game, you have more boards than you have atoms in the universe. So it's a complex problem, and you can't brute force it. Like you can't have a sweep through all the board configurations and then choose your best move. You can't do that. You need to have an agent that can reason and can look forward towards like the search tree and see which move it should take in order to win the game. And AlphaGo came up with a move by the human standards. It's a bad move. It's the move number 37. But actually, the reason why AlphaGo won that game, and it's not like I would say by coincidence, because it did win twice. So as you can see, 10 years ago, we had an agent that is capable of like showcasing deep reasoning skills and even beating the best human at what they do. And this is the era of experience. It was like this is a paper that's been published, I think, a month ago. It's not a paper; it's more like a preprint that would be part of a book for Richard Sutton. So the people who published this paper, they are like David Silver and also Richard Sutton. To me, I regard as the goats of reinforcement learning and one of the, I would say, titans of machine learning in general. There is a famous book from Richard Sutton called The Reinforcement Learning Introduction that I really recommend to everyone who wants to start his journey or her journey in reinforcement learning. what we're gonna do today is that we're gonna go through this paper, in order to have an overview of how this era gonna look like and how this shift gonna happen and how you're gonna prepare yourself for such a shift if it ever happened. You never know. The field is moving fast, so it can happen tomorrow or next month. But what I'm sure of personally, that this must happen in order for us to reach AGI or even ASI, which is the artificial super intelligent, where we can exceed human performance in some complex tasks. So this is the talk for our night. This is a way of navigating the era of experience-driven reasoning. And we're going to discuss 4 points into details. First is the autonomy unleashed. It's the shift from data to experience. The second, we're going to have like a rewind in order to introduce reinforcement learning. It's the thing that we forgot, but we still need. Third, we're going to discuss the golden circle, why we need this shift now, how we're going to have this shift happening, or how we're going to manifest this shift, and for what reason you should be focusing on such a shift if it ever happened. At the end, it's sort of like a funny title. It's Agents Wanted, a Bond-like section where I'm trying like to share with you some of the personal opinion on what you need to take a look at in order to equip yourself with the right tools to assist such a shift. So starting with the autonomy unleashed, as you can see on the right, here is an evaluation of, I would say, the best LLMs when it comes to solving some of the problems, like speech understanding, image understanding, handwriting understanding also, or even like writing like a complex report. But if you look closely, you can find that complex reasoning is actually is where these LLMs performs worse. And it's not a surprise if you know how these LLMs been trained. They weren't trained to solve such complex reasoning tasks. They were trained to be a useful assistant. So now we see people deploying such LLMs to solve complex tasks, and at the end they perform badly because like they are actually blind. They don't have an idea on the consequences of their decisions on the world in the form of feedback from, let's say, simulations or like simulators, or even, let's say, if you are in a lab and you are experimenting, doing some experimentation, if the LLM asks you to do something, there is no way the LLMs can look deeply into the results unless the human would prompt back the LLMs with the results. And here it comes the problem. When the human tries to prompt back the LLMs with the results, you can have all the problems human suffers from, like bias, or even you can have blind spot that humans would ignore. Move 37, as I've mentioned, it's one of the clear arguments that sometimes, or most of the time, humans have blind spots when it comes to complex tasks. So as I mentioned, these LLMs are tuned to appear right, most often blind to the consequences of their actions. So they are not trained to optimize or adapt to the outcome of their decisions. And if you give me another argument that we can train LLMs on data that is built around these complex tasks, I would tell you there is a fact that we may run out of data very soon, like in 2027 or 2026, we may run out of data, because as you can see on the chart, like in the chart on the right, you can see Llama 4 basically being trained on most of the data we have on the internet. And by 2026, most of the data available on the internet are going to be consumed by these LLMs. And if you are lucky, you get access to closed data, but most of the time you can't because of privacy reasons. So we are desperately in need of ways to train these LLMs to solve complex tasks without actually the need of more data coming from the web, let's say. Some of you would say maybe mimicking human reasoning is the solution for such a problem. It can work sometimes for some tasks that are moderately complex, but it's not enough. Like prompting techniques can help with creating human-alike reasoning traces, but are not necessarily correct, nor they can adapt. So even the way you're going to prompt the LLM to solve such complex tasks can suffer from bias. move to C7, or even like it would limit the LLM's capabilities to exceed human performance, like it did in Go or in chess with AlphaGo. Some other methods try to fine-tune the LLMs on the human traces. It can like work really well compared to actually training from scratch. As you can see on the right, by just having a post-training enhancements, you can have the same performance as spending the same, like 5 times the compute and training the model again on such traces. So overall, there is a step towards this, towards solving the problem of deep reasoning with efficient prompting and with some useful pre-training or fine-tuning, but it's not sufficient to solve most of the complex tasks we dispose of now in the industry, let's say. This brings us to the era of experience. So we are trying to teach agent beyond imitating humans, but actually interacting with the world. So these agents should learn from observations, actions, and also consequences to optimize for long-term goal. Not a short-term, it's not like a dialogue you're having with a human where you try to craft the best response possible, but it's more of like the agent try to optimize for a long-term goal by taking multiple actions towards this goal, and each time tries to see if it needs to change its policy in order to achieve this goal. So there are 3 pillars here. The agents operate continuously, not in static prompts. So the agents can interact with many tools, and it can like react to the output coming from those tools. You don't need a prompt coming from human in order to let the agent react. Second point is learning is driven by rewards grounded in the world. So not necessarily like human feedback reward, but you can like pull many metrics from the simulation engine, or even from the world you are operating in, and feed it to the LLM or the agent in general in order to come up with, not the agent, sorry, but it's more of like feed it to a heuristic that you crafted to come up with a reward, or sometimes even a model in order to predict reward for the agent, like your core agent, to adapt to. The third point is knowledge is built through trial and feedback, not just from data. So you can have like a limited set of data that you can start like from. Let's say first you have a set of data that you apply behavior cloning in order to learn like basic skills. Then eventually using a reward, you're gonna build on top of these basic skills in order to exceed human capabilities, let's say, or even cover the blind spots the human neglected. And all these propositions, lead us to reinforcement learning. It's kind of funny because it's kind of like the baby we thrown with the bathwater. It's a famous quote. We neglected it recently. I think it's because of especially the hype of having like GPTs around. But if you remember 10 years ago, we had like a big hype that reinforcement learning is the way we're gonna reach AGI or even ASI. And I think it's coming back now. Briefly, like what is reinforcement learning is just a loop where you have an agent and the environment. The agent is trying to interact with the environment. This environment can be the real world, or it can be also a simulation environment. The agent gonna act on such environment, then the environment gonna respond back by a new state. Let's say you have a cup, you move the cup, then the cup gonna move from point A to point B. So point B is your new state, let's say, and you have a reward. It can be 0 if nothing happens, or it can be like a positive or negative values if actually you enhance the state of the system or like you made it worse. So the goal here is that how the agent can learn in an episodic fashion that there is a good policy it can achieve in order to maximize the long-term reward for each episode. And this problem is differentiable. You can solve it with machine learning. We have a lot of methods that can solve this problem. Some of them, like they are policy-based, some of them are model-based. But if you want to go deeper into what are the methods we actually do use to solve these kind of problems, I highly recommend the book from Richard Sutton, Reinforcement Learning and Intellection. as a rewind like for the last decade, we had many breakthroughs when it comes to applying reinforcement learning agents to solve complex tasks. Even recently in 2024, 2025, we had like people coming back into going all in when it comes to reinforcement learning agents. So in 2015, we had AlphaGo from DeepMind. It was state of the art of playing Go. Then in 2017, we had AlphaZero also from DeepMind, played both Go and chess and exceeded human performance in both games. Then OpenAI catch up with playing Dota 2 in a multi-agent fashion. That was like a huge breakthrough also in 2018, where Dota 2 is actually like a game where OpenAI actually uh, ranked first when it comes to the performance of their agents on this game. In 2019, DeepMind also came up with the game-focused agent called Alpha Star, where I think the game was called StarCraft 2. It actually excelled at this game and by beating like humans in these games. And then DeepMind went even further with MuZero, where we have like a model that doesn't need to like you have an agent that doesn't need to doesn't need to know about the rules of the game, so you can feed it any game and it would learn the transition function. They fed it like I think Atari games, Shugi games, Go, and also chess, and they actually matched the performance of AlphaGo in chess and also Go, and also matches like the performance of state of the art when it comes to Atari games. Then we had the kind of the break by having many GPTs being released. So people like drifted a bit from releasing like new state of the art agents. But recently in 2024, DeepMind came up with another agent called Alpha Proof, which achieved like several medal standards in solving international mathematical problems and also like proving some theorems. And it's based both LLMs and reinforcement learning techniques. And of course, recently you've heard about DeepSeek. They actually like sorry. They cause like the stocks of most AI companies to drop. It's because like they trained an LLM with way less cost compared to other competitors. But the funny thing is that they had a version called DeepSeek Air 1.0, where they went from the base model. So we know that when you train LLM, you have three parts. You have the part where you create the base model, then you have like the supervised fine tuning, and then gonna have like the alignment with LLHF. Mostly people use that. So they went from the base model directly into training an LLM using a reward function that is a heuristic base. It's not even LLHF. It didn't quite perform same as the one trained with SFT, like with supervised fine tuning, but it was surprising that you can actually do that. And 2 years from now, probably we're gonna go from the base model into an RL model that is training in RL fashion, interacting with heuristics without even the need of human intervention with like a human label the dialogue if it's like a bad or a good response. That was actually amazing, and I think uh, probably 1 year from now we're gonna have two parts where you do have the base model, then directly you do have like an RL model like training pipelines where you try to learn the reward, like trying to learn to optimize your reward given many interactions with the environment. In this case, it can be like interacting with a complex problem, let's say mathematical problem or like coding problem, where each time the agent is trying to improve its behavior given a reward signal. Yeah, so now we do understand the importance of the era of experience. We do understand also what is like the core of this era, which is like reinforcement learning. Now we need to answer further question, is that like why we do need this now. Probably we answered this a bit by talking about the LLM falling short when it comes to complex reasoning, but also we need to answer the how to, like how we gonna let LLMs or agents in general being capable of solving such tasks using reinforcement learning. And at the end is like what for? We know LLMs are good. So if we solve these tasks that are like complex reasoning tasks, what would be the added benefit and where it would lead us. So why experience matters today? I think it's a natural phenomena happening following the hype cycle that like dated 10 years ago. First, we had the Atari, then the hype took over, especially with AlphaGo and AlphaZero. Then GPT came up, everything like dropped, and people like shifted focus into another thing, and eventually like people start to being more like reasonable regarding their expectations from model trainers supervised learning fashion, and now they know that you do need reinforcement learning models that train along with simulation environment or even the real world in order to optimize for long-term reward or long-term goals. And it's the right moment that we do need, like we need this shift, because we've made like significant progress recently, especially with simulations, tokenization, multimodality, agentic tooling. Now people are more open to integrate their tools with agents, especially with the MCPs now being the big hype, taking the scene. And also we've made significant progress into understanding LLMs and multi-hop reasoning. Like, can LLM actually have a multi-hop reasoning in abstract fashion, or do they need like special prompting techniques like a chain of thoughts or tree of thoughts, let's say? And we have an early sign of that, which is the release of Alpha Proof and also DeepSeek R10, as I've mentioned, because they made the first step towards having reinforcement learning focused pipeline to train LLMs. And how to manifest this more technically is by ensuring that we do have these three parts guaranteed. First, we need the streams, the actions and observations, and also rewards. We're going to go through the details of each now. First is the streams. So a stream-based agent maintains a state optimized for long-term horizons, as I've mentioned, and also improve via interaction-generated data. So you always need a stream of data coming to the agent, resulted from the agent interacting with the environment. And from there, you're going to have what we call a non-stationary policy, where you each time trying to improve upon the previous policy and adapting a bit your probability distribution in order to optimize for long-term goal. So what you have is three main things: stateful execution. You're always trying to execute, have a state, new state, and you're going to internalize that state. Eventually, you're going to build I would say what we call a memory of states that you're going to use in order to pick your next action. And this kind of define what is Markovian observation is. You're going to find it usually when you read about what we call the MDP, or like a Markov decision process that is used to train reinforcement learning agents. Second thing is trajectory optimizations. As I mentioned, we always try to optimize for long-term goal. We don't need to sound right, but we do need to be right on the long term. And on data generation. As I've mentioned, we are in a shortage of data now, but with reinforcement learning, we don't just generate data, like synthetic data that we can train on later, but we train data where the quality improves with time. Because if you're gonna have an agent with a non-stationary policy improving with time, the data you're gonna generate are gonna get better and better and better, to the point where you're gonna discover patterns you wouldn't have discovered if you generate this data from a human labeler, or even from an agent with a stationary policy, like the policy that didn't change, because you're gonna have the same quality output it again and again. The second thing is actions and observations. This is self-explanatory. Agents must perceive and act through general interfaces beyond text I/O. So when LLMs first been released, like in 2019 and 2020, it was mainly text. But with time, we've made significant improvement when it comes to tokenization. Now LLMs understand byte pair encoding is a significant step towards making LLM do coding, because they deal with coding better than, let's say, sentence-based or character-based tokenization. So we can go beyond text by having more specialized tokenizers that we dispose of now. We adapt them for many observations types, and we can feed these LLMs, these observations as tokens. And then we can take advantage of multimodalities interactions between many types of tokens. It can be like speech or text or image tokens. And from there, you're going to have like a performance you never imagined before, because you're going to find that the agent is capable of discovering a lot of blind spots a human would never seen before. Interface generalization. So even the LLM now can operate on interfaces. I think OpenAI released, I forgot the name, but it's like it's a tool where you're gonna ask the LLM to do a task, ask ChatGPT to do a task, and GPT gonna navigate the web for you. This is example of LLMs or agents being able to interact with interfaces. At the end, I think this is the most important part, is the rewards. Now, LLMs are probably coming short when it comes to solving deep reasoning problems, or even exceeding human results, because it's the human providing the reward by labeling the output of the LLM is good or bad. But if you're gonna have like a grounding reward signal coming purely from the metrics the LLMs is, or the agent is receiving from the environment, and you're gonna have a heuristic or even a reward model trying to come up with a good reward to give it to the agent given the action it took, then I think you're gonna have like much better improvement or like much better relative improvements compared to human performance in this task. You can most of the time exceed like the human performance. So LLMs use static human scored rewards. This is bad. Me personally, I think this is bad for a set of problems that are focused on the industry. Maybe for other sets of problems, human rewards are good. Let's say if it's like problems regarding LLM generating a poem, I don't think you're going to come up with a heuristic that would evaluate how good is a poem, but it's highly subjective, so a human can label that one. So the second thing would be user-aligned reward modeling. We can combine feedback coming from the human, as I've mentioned, and also from the heuristics or reward models that we've built. And what for? What experience matters for today? I think the goal is to reach AGI and also reach ASI, which is artificial superintelligence. We are now in like an artificial neurointelligence, making our leap towards AGI. But if you want to create an economical growth that would be significant, let's say 5% growth in the world GDP, then you would need ASI to happen, where you don't need just to match the human intelligence in some of the complex tasks, but you would need to exceed the human capabilities in, let's say, designing chips, or even like doing end-to-end lab experimentation to come up with new vaccines, or even like proving some theorems, or why not coming up with new theorems. And these systems need to be able to adapt to the environment they are working on. They should be able to reason. They must be able to reason in an abstract or even like a tokenized fashion. We can like see the traces of their reasoning and have sort of interpretability. We should be able to interpret their reasoning traces, because that would allow us to increase our skills also, because we can learn from these models. The last question that we should answer is, let's say we're gonna make this shift, then how are we gonna equip ourselves with the right tools or the right knowledge to assist it? I would recommend 3 things. The first thing is revisiting the learning loops, which is revisiting reinforcement learning breakthroughs from U0, AlphaGo 0, and also like OpenAI Dota 2 performance, where we had like the amazing multi-agent algorithm relying on PPO. So these are all papers, although dated 10 years ago, 7 years ago, or even like 6 years ago. But I think it's gonna be a great read, because it would inspire you on how you can solve especially industry tasks where you do have a model of the world most of the time, and you do have like many actions you can take, and using LLMs as they are now is not the right choice, or probably you would fall short taking LLMs as a way to solve such a problem. Also, using reinforcement learning agents doesn't mean that you don't rely on LLMs, but LLMs are just like any other models that you're gonna use within the training pipelines to achieve achieve a goal, which is solving complex tasks. So recent works from DeepSeek V3, R1 also, and R10 is like they have a technical report where they go through the details of how they tweaked like the reward for their model, and also they come up with a smarter way to in order to decrease the cost of training. As you may know, this is the big reason most of the stocks dropped once DeepSeek have been released. Alpha proof is also like right step towards this direction, because if you take an LLM alone and you don't train it, but you just use prompting techniques to solve math problems at the level of like a math Olympiad, you're gonna fall short. But using reinforcement learning techniques, they actually push the agents to prove theorems and also coming up with new ones actually. The last thing with this is interesting. It's from text outputs to tool use. I don't know if you heard what MCP, Model Context Protocol, is. It's a sort of like a protocol where you can rely on in order to let like your LLM or agent use many tools. So now, if you do have, let's say, a website, you do have an API, or you do have a tool, and you want to expose it to an LLM, you can follow this protocol, and then the LLM can have access to a wide variety of tools. From last time I made the talk, it was the weather API. Now you can like use an LLM to do like really, really complex tasks. Like, for example, now your LLMs can access like structured data. I would say tools. For example, it can access Slack. I saw that day that you can actually do that also. That's nice. And if we follow these tools, then we're gonna get into what Andrej Karpathy described as the LLM OS, where you're going to build an operating system where the LLM sits at the core and everything else around the LLMs is plugged into the LLM using kind of protocol, which can be the model context protocol Anthropic came up with. I would say this is more of like a blueprint on how this shift is going to happen. We don't know if it would happen actually, but I think I bet it would happen. And as they say, as you start to work on the way appears. I think the more we're gonna have people moving towards LLMs that can solve complex reasoning tasks by relying on like environment feedback, the more you're gonna see that the industry or even like the labs are shifting towards the era of experience. So let's see. Probably like in the next talks, 3 months from now, 4 months from now, we're gonna have a different era, but most probably I think they're going to be like the era of experience. I hope these talks benefit you somehow, and happy to take questions.
Okay, thank you very much, Azzeddine, for your very great, very interesting presentation. It was so enlightening, mashallah. So we're gonna take a couple of questions before we end. And we have the first question. It says, in reinforcement learning, the reward design usually seems intuitive, yet how to design rewards in open-ended or complicated tasks that agents may operate in, as you mentioned, human feedback and heuristics.
This is actually a good question, because I would say we're doing reinforcement learning for the last 5 years. The most headache you're gonna have is from the reward function. It's hard to design, but I think it's require like a combination of two things. It's like knowledge, domain knowledge. If let's say you are like in my case, you are solving a problem for chip design, then you need to be highly knowledgeable of how you need to design a chip. For example, in the case of alpha proof, you need to be highly knowledgeable of how you're going to evaluate the theorem proof. Eventually, let's say this is step one. If your problem can be objectively evaluated, the hardest thing I think is when you have problems where you don't need. It's sort of like an art. And let's say you're gonna have generate a poem or paint something, and you can't be the heuristic for that. Probably for the poem, you can do some some tweaks of how like the symmetry and the rhythm and also other stuff. But I think at the end you need subjective reward. At that time, what people probably came up with is that you're gonna build the reward model that doesn't take only the observation, which is like the output of the agent, but also the metrics that came up with the with that output from the simulation environment. And then also you can feed it the feedback from the human. And from there, you're gonna let the reward model output a reward and see how the agents interact with that. So even the reward model can be trained by having three, like let's say three inputs, and then the reward model gonna try to shift its focus on one of these inputs given the state it is operating on. I highly believe that this is like an interesting question because like people still suffer with like observations where they don't know if they're gonna rely on human feedback only or use metrics. Most of the time, I think combination of two is good, but I would lean towards like having heuristic rewards as much as I can because it's easily manipulated compared to a human reward where it's highly dependent on the human evaluating the agent response, and you're gonna have like a data shift within your human feedback data set without you knowing if you do have different kind of human, let's say, evaluating the same output from the agent differently. Yeah, I hope this answers your question.
Perfect, thank you. We have a second question. It says, is the current reinforcement learning algorithm state of the art still suitable in LLM or agents context, or is there a need to focus more on agents adapted algorithms such as for long horizon problems?
So what I know is that when LLHF came up first, like people started using the out-of-the-box algorithm to train reinforcement learning agent, which is PPO. Then weirdly, we found that like a reinforced algorithm can behave same as PPO. It's much simpler than PPO, but can behave same. Then they come up with a new algorithm. I forgot the name because I don't personally work on LLHF, but it's a way simpler version of PPO actually, and it did perform really well. I don't think there is like there is a big difference between training a simple reinforcement learning model to solve an Atari game and training like an LLM to align it to human feedback, except you coming up with a good reward system. Probably there are some tweaks here and there because it depends on the architecture of the model, etc. But the blueprint, if you look at it like from above, it's gonna look the same. You do have a reward, the trajectory, which are like the set of tokens your LLM is generating, and then you're gonna back propagate in order to do what we call credit assignment to increase or decrease the probabilities of some tokens. It's nearly the same. And the good thing is that, as I've mentioned in the poem at the beginning, is that we explored many paths. Now we are coming back into where we started, but we are looking at it differently. Now it makes sense. Things click. We know we have reinforcement learning. We know LLMs are good. Transformers are great architecture, scalable, and easily interpretable. Like you can like interpret it really well. So now it's just like putting the system in place and plug it in into as many tools as we can, and like embracing the era of experience. So we don't like stay close into how we can just train LLMs the old fashioned, but we move towards a different way of training them, more focused on reinforcement learning. I hope this answer your question.
Okay, thank you. We have one more question. It says one of the most complex tasks in LLM apps or agents is the prompt design. Will agents be one day be able to transform simply prompted instructions into complex reasoning and orchestration?
Okay, I would read this question again so I understand it. One of the most complex tasks in LLM apps agents, okay, is the prompt design. Will agents be one day be able to transform simply prompted instructions into complex reasoning and orchestration? So if you look at the recent models, like the reasoning models that are coming up from DeepMind, from OpenAI, from even like the DeepSeek company, one of the steps they do is that, of course, they have a chain of thoughts or even like tree of thought sometimes. If you use like OpenAI, I would say recently, you can see the reasoning traces. First thing they do is that they try to change the prompt. So sometimes like the user inputs something, but it's not necessarily the right, like the good prompt, the good way to manifest this prompt. So what they do is that they try to optimize the prompt first, probably make it shorter, make it like more straightforward, and then they feed it into the actual LLM making the prediction. Whether like it's gonna translate the user prompt into more complex prompt, I think this is already happening, because if you use, let's say, chain of thoughts, it's like a mimicking of human traces. You're gonna take a simple question and then adding like a zero-shot example of how you're gonna solve a problem using one of the human thinking traces. The LLM can come up with like given like intermediate tasks that you're gonna give it within the prompt. You're gonna come up with an output, then you're gonna feed it again recursively to the LLMs in order to come up with with another decision, and feed it again recursively while you are respecting the context window you're allowed to use. As long as you can do that, you can build like a complex prompt that eventually you feed it to the LLM. I think we are already doing that. Whether we need more like complex prompts, I don't think we should have complex prompts, but we should have more descriptive prompt where you have like a prompt covering the state of the environment we are operating on. Me personally, working on industry problems, I think about having the right metrics and the right observations from your simulation environments, but it can be a different thing for like someone building LLMs for as an assistant or something. I hope this answered the question. It's not like I would say straightforward like answers, but I hope it does the work.
Okay, thank you very much. I believe this was the last question. Thank you very much, Azzeddine, for your enlightening presentation today. It was so interesting and very great. And it was, in fact, our pleasure and our honor to have you with us again in AI Summit 25. And yeah, thank you everyone for coming to today's session. See you inshallah next time for another exciting topic, more multi-agent reinforcement learning.
Thank you for the invite. Bye bye.